Hello. Eukaryotic transcription is mediated by three different RNA polymerases. RNA polymerase 1, 2, and 3. 1 is specific for transcription of rRNA genes mostly. 2 is the one RNA polymerase 2 transcribes majority of the mRNA encoding genes and others. And RNA polymerase 3 is involved in the transcription of tRNA genes and others, other small RNAs. And of these, the best understood in terms of transcriptional initiation is that of RNA polymerase 2, and that is what we will try to appreciate or understand at this time. The first point is that when we have the promoter element which has several factors, several elements, and then we also have several corresponding factors that bind to unrecognized. Something like we have the elements like Tata box, we have TBPs which will bind to Tata box, for example. So here we are starting with the Tata box, and that's where it is nearby the initiator, and to which is recognized by TBP, Tata binding protein, along with TF2D, and that causes a bit of a distortion in the DNA, and there is conformational change, therefore the affinities would also change, and that allows the recruitment of TF2A, transcription factor for code 2 for RNA polymerase 2A, and that will also allow the recruitment of TF2B. The function of TF2B is to recruit RNA polymerase. So once these factors are bound here, the next step is to bring the RNA polymerase 2 to the promoter. So because of TF2B, RNA polymerase comes in along with that of TF2F. TF2F is important for loading of RNA polymerase to the promoter. And once RNA polymerase is bound, we call that as pre-initiation complex. It is because RNA polymerase is not yet ready to transcribe. It needs further factors for transcriptional initiation. So we have several factors here. We have TBP, TF2D, we have TF2A and TF2B, and we also have TF2F, and along with that of the RNA polymerase. That is for the formation of a pre-initiation complex. Then we have the recruitment of TF2E and TF2H. So E will help the recruitment of TF2H. H is important for several reasons, because it has it's a multi-subunit protein, and it has helicase activity. So it will start the little bit melting near the initiator and Tata box. There will be melting of the DNA, and the second one is further important. It also has kinase activity. If we remember the RNA polymerase, it has a tail like thing like this, and what happens to the tail will determine the activity of the polymerase itself. So all is in the tail in a way. So TF2H is the one using its helicase activity. It's going to phosphorylate several residues, serine residues present in motifs. So YPS TSPS, which stands for, it is a motif within the carboxylic terminal of this RNA polymerase. It is for tyrosine, serine, proline, threonine, serine, proline, serine. So within these, as we will see later, the way these phosphorylation occurs within this motif, there are multiple motifs on this tail at this place, and based on the phosphorylation of it, the activity of RNA polymerase happens. As we see at this stage in the pre-initiation complex, and followed by the binding of TF2H, RNA polymerase still has active affinity for the DNA, as well as the several factors that are bound in this location. But this all changes once there is phosphorylation on this on the tail of the RNA polymerases. I mean, once phosphorylation occurs, it loses affinity for these factors, and it will start initiation of the transcription. And that is when the RNA will keep on coming out and RNA polymerase will move further. So the post-translational modification of the specific residues is changing the way the affinities of RNA polymerase with several other factors, and that is causing the initiation, in this case, initiation of transcription. So there are several factors that are involved in this case, and in that we have several TAFs, that is startup binding protein associated factors. There are at least about 10 different types of TAFs, and they have little bit of similarity or homology with that of the histones. And TF2B is a single polypeptide. It is the one that interacts with BRE, TF2B recognition element, and Tata box, and also can contact with or interacts with the RNA polymerase 2. TF2F associates with polymerase 2, and the important function is to stabilize TBP, DNA, and with TF2B. And similarly, we have the TF2E. The function is to recruit TF2H, and TF2H is kind of switch between formation of preinitiation complex to initiation itself, and that is dependent based on the ATPase activity and the protein kinase subunits, and that will result in the promoter escape. So we can appreciate, compared to that of prokaryotic transcription, eukaryotic transcription is much more complex, because there are so many other, because it's complex as a form of chromatin itself, and then there are many factors that are involved in the transcription. See you later. Thank you.